Students, you are given this question. Kindly study the question good and complete all the steps. The time limit given to you is 5 minutes. Students, we are given this question. Show that the equation 4x cubed positive 8x squared positive 11x positive 4 is equal to 0 has exactly one real root. Now, foremost, we have to consider the given polynomial 4x cubed positive 8x squared positive 11x positive 4 equal to 0. Now, the most important observation you have to perform here is notice the constant 4. In the previous question, we were given that 4x cubed positive 8x squared positive 11x positive 9, and then we were asked to divide this quantity by 2x positive 1. And if you would have noticed, we got a remainder 5. So that would mean if the constant was 4, then this quantity 2x positive 1 would factorize this entire polynomial without leaving the remainder 5. But we were given the constant as 9. So that is the reason we got the remainder 5. But in this question, the constant is 4. So clearly 2x positive 1 will be a factor. So you can write that by the following statement. Clearly 2x plus 1 is a factor of 4x cubed positive 8x squared positive 11x positive 4. So this would mean I can write the given polynomial as 2x positive 1 times. In place of this, I need to put in the quotient. So the quotient, if you would have seen in the previous problem, we got it as 2x squared positive 3x positive 4, and that has to be equated to 0. Now, clearly from here, this means 2x positive 1 is equal to 0, which means 2x is equal to negative 1, which means x is equal to negative 1 over 2. So this is a root. Now, from here, 2x squared positive 3x positive 4 is equal to 0. Now, if I were to use the quadratic formula, x equal to negative b plus or minus root of b squared negative 4ac divided by 2a, then my values of a would be 2, the values of b is 3, the values of c is 4. Substituting it, you would see negative 3 plus or minus root of 3 squared negative 4 times a times c divided by 2 times a is 2. So if you see the discriminant, I want to use the space. The discriminant is root of 9 negative 4 times 2 is 8. 8 times 4 is 32. So this is nothing but, you see this, a negative value. You understand the value inside the square root gives me a negative value, a negative quantity. So this means the roots cannot become real. So you can directly conclude this implies the roots cannot be real. So even if it exists, the roots cannot be real. So that is a very important observation. So why? Because since the discriminant is less than 0, so that is the reason. Because the discriminant is less than 0, the roots cannot be real. So this implies, I'm using this space here, okay, so this implies the polynomial, the given polynomial as just one real root, hence proved. Okay, so that completes the solution for this question.